Okay, today we're still on 10.1, day one, and we're just kind of like reminding everybody what we did yesterday. And we'll move into a little bit of tougher stuff in a little bit. And then this is going to be a really short lesson, basically just wrapping up yesterday's. And your homework for tonight, I'll tell you already, it's going to be to finish the homework that we started yesterday, 10.1, day one. All right, this is a helper triangle. I like to call it a helper triangle anyway. And it's got the 30, 60, 90. And I'm setting it up in the same orientation. You know, this weird upside down kind of feels upside down to me anyway, triangle. And I'm going to set up the sides. 1, and please tell me where that 2 goes. On the hot noose. The 2's on the noose. And then this is square root of 3. 1, 2, square root of 3. If you set that up right, then you have a chance of getting it right. Tell me which one goes with the Q. Q goes with like. And what do I go do next? Well, there's nothing here, so I can't really use this side. So I'm going to leave that alone. What do you think is next? Q goes with 2, like, there you go. 2 goes with 1. And now, yes, you can cross multiply. If you like doing 3 steps, you want to just do 1 step, what do I times both sides by? Super fast and I'll be done. Times by 2. You need to learn how to see the fraction and clear it. Use times by the denominator. Final answer, Q is 4. Raise your hand if you had that one right. All right, awesome. Let's do another one that's like that. This one, funky looking, 45, 45, 90. And remember, even though that might look to you like it's not 90, if it's labeled as 90, the drawings are not to scale. You can trust the labels. So this is a 45, 45, 90. They don't always label all 3 sides because they hope you're smart enough to go, well, the third one, it has to add up to 180, so I can figure out the third one. And let's say at this time, this side's going to be square root of 8. Would you please figure out for me what x and x are? Obviously, they're the same thing. If I were you, I'd set up the helper triangle. How many of you knew it was 1, 1, square root of 2? Good, you're supposed to. You're supposed to have it memorized coming in today. If you didn't do your homework last night. You were supposed to learn that. You've got to keep up. You can't afford to try to learn it all at once at the end. It won't work. All right. Ms. J.S., tell me how to set this up. Yes, you could start with square root of 8, but I wouldn't. Remember me saying to start with the variable? There you go. I know that's being picky, but I've seen so many kids set them up in ways that just like end up biting them later. Like if you had set it up this way, start with that 1. And you could go 1 is to x, like square root 2 is to 8. But then you got to deal with the x in the denominator, and that's a pain in the butt. If you do it the way I just suggested, what question? You're right, thank you. And if you do it like I just suggested here, start with the x. You see, I don't even have to multiply it by anything. It is done. That'll often save you a step if you just start with the x. Now, some people say, well, can you leave it this way with square roots on the top and the bottom? Yes, you can. But there's a thing called rationalizing that I want to just briefly talk about that sometimes they're going to do. My 8 went bad. That sometimes they're going to do, and you need to understand what they're doing. Once I get this down to just x equals, I could leave it that way. Or sometimes the book is going to say that the answer is something different. And you're going to be like, why in the heck do they have this weird answer of square root of 16 over square root of, let me think, square root of 4, which is really 4 over 2, which is really 2. Get what I'm saying? The answer was 2. And we thought it was this. So what did I do there? I multiplied by root 2 over root 2. And rats. It's been happening more frequently lately. All of a sudden, my smartboard just disappeared, and everything I had written on the board. Guess I'll recover the lost file. Let's see if it's the one I was just writing on. Seems like the smartboard's got an issue when you drop your marker into the tray. Nope, that's not what I was just writing on. Okay, so where was I? Oh yeah, I was talking about this kind. Let's say you had 1 over square root of 3. What could I have instead? Square root of 3 over square root of 9, and that's really square root of 3 over 3. Do you get that the black one and the red one are equal to each other? You need to be able to do that. That's called rationalizing. Rationalizing what? Well, these are irrational numbers. But when you get the square roots off of them, like you get them to work out perfect like this, then that's a rational number. Technically, a lot of books and even professors in college won't let you leave a square root in a denominator. Because when you're dividing by something that never ends, because square roots that don't work out nice, they're actually never-ending decimals, you can't really divide by something that never ends. Strange, but true. All right, so if you see this, you might also see this on an answer key. And you need to get that they are the same thing. So one more like that. Let's see if you really caught what I was trying to say there. Let's say that this was your answer, and it's the ACT, and you're confident you're right, but that's none of the choices. This is an example where the ACT might have rationalized the denominator. Figure out what the answer could be by multiplying by something. If you figured out what I was doing, you'll be able to multiply by that and get the new answer. I'm going to pause for a second, see if you got this. Okay, so for this one, we multiplied by root 5 over root 5, and we got 2 root 5 over 5. All right, so that's enough about talking about rationalizing. Let's get to just some plain old-fashioned harder problems. If you have a triangle that's a 30, 60, 90 triangle, could you put another triangle in it that's also 30, 60, 90 that's like nested in there? Like that? Do you get that the red one would also be a 30, 60, 90? All right. So let's say that I knew this end. No, actually, let's not say that I knew that end side. Let's say that I knew this height of the triangle. And I said that the height of the triangle was 8. You should be able to figure out how long this side is down here. Actually, I'll make it this one so it's really clear. That side, x. And a lot of people, you know what? I made this a little too easy. I should do the bottom one here. I'll do the bottom one. So x, just to make it really clear, x is that distance right there, that whole thing. So this has a triangle in a triangle. This is a little more pre-calc level. This is not just algebra level. In fact, this could have been a hard one in algebra, true. Geometry, one of the hardest ones in the test kind of thing. But for us, this is like the easy kind. Now, my advice for you is this. Don't just try to figure out x right off the bat. Usually you figure out that there's something else you got to figure out first. You know what I mean? And then you'll be able to figure out x. Whenever I have nested triangles, and I'm telling you this, I really do this. Whenever I have nested triangles, I try to pull out the separate triangles and write them separately. Like this big green triangle. Would you please pull it out, write it separately, and label its sides that we know. We don't know everything, but we know it's a 30, 60, 90. Then pull out the red one and label the sides that we know on that. And also, that's 30, 60, 90. Label all the angles. It's 30, 60, and 90. And then last but not least, realize what side they share. All right, so pull out the green one, label it. Pull out the red one, label it. See which sides they share. I want to pause for a second and have you try to figure out X. It's just another 30, 60, 90 problem. It's just got one extra step. All right, now pause for a minute while you work on this. Okay, look at your two triangles. Did you label them properly? Do you get that the green one on the left, we don't know any sides on it? Unless we want to say we know that this is X, but that's not knowing what the side is. Do you get that you can't start with the green triangle then? You don't know a side. You can't do it unless you know a side. All right, so then we can do something on the red one though, can't we? Thank you. So, thank you very much, sir. And this one, I can figure out any of the sides. Which side do I want to figure out? I want to figure out its hypotenuse. Because did you figure out that the question mark there goes with the question mark right there? Those sides are the same. You see that? And we can't do anything in the green one, so that's why pulling them out is smart. When you realize, oh, I got the side on that triangle, you can figure out any sides in that you want then. All right, so use the red triangle and do the whole helper triangle thing, and then figure out how long that side is. And since these are the same thing, then you'll be able to use this side to help you find X. So you got a couple more steps here. I'm going to pause while you give this a try. Okay, I'm going to help you get a little bit further here. With that little helper triangle, you need to draw these helper triangles in there. That way you can set up your little proportion and you go, where do I start with? The variable. I'm going to rename the question mark. Did some of you guys give it a letter like A or Q, or what did you guys pick? Y, and I heard a T and I heard something else. All right, I'm going to call it Y. And then I'm going to say Y is to 2 like what? 8 is to square root of 3. Very good. And I'm going to times both sides by 2. And now I get 16 over root 3. Raise your hand if you had that right. Awesome. Now, if that's 16 over root 3, then that's the same as that. So that side is 16 over root 3. Now you should be able to set up a new 30, 60, 90 helper triangle. I guess you could even use this one. It's already there, but its orientation is different, so it might mess you up. I'm going to set up a helper triangle right here that's in the same orientation as that first one is, so that it doesn't get me all confused. And this is 1, 2, square root of 3. Now I can say final answer that X, I'll start with the variable, right? X is to 2 like 16 over root 3 is to 1. And 16 over, dividing by 1 doesn't really do anything, right? So then I can just times top and bottom by, or sorry, times both sides by 2. And final answer, X equals 32 over square root of 3. Now, that was not easy, I know. Yes? Good question. You do not need to rationalize answers. I was only telling you that because there are times when the answer key that you're going to look at has a rationalized answer. So if you're like, I'm pretty sure I'm right, but this answer looks different, I want you to be able to, in your head, know you could just go square root of 3 times square root of 3, and that could have been 32 root 3 over 3. Okay? Follow up? I will accept either answer on the test. Good question. I actually think most people aren't going to think about rationalizing, so that's the answer I'm going to see more often. And you're not required to rationalize. So here's what the calc teachers will tell you. Since they don't require you to do it, don't do it. Because if you mess it up, they will mark it wrong. So on a typical AP test, where you're all probably going to be, not all, but most of you are going to be taking an AP test at the end of next year, you don't have to simplify on the AP test, and you don't have to rationalize on the AP test, and therefore they're going to tell you it's hard enough to get to the answer. Don't go and try to simplify it, because if you do mess up the simplifying, there you've gone and lost a point instead of like trying to get more points. You won't get any more points for simplifying or rationalizing. So I will do the same thing here. I'll say, if you want to rationalize, go ahead, but you're taking a risk that if you screw something up, and you're going to end up maybe losing points you wouldn't have lost. All right, so now your homework. What do you mean your homework? We haven't taught us anything. You're right, but you have everything you need, and the person next to you also has like the same exact assignment as you, and the problems that are just like the one I just made up, we're going to just do some more from your homework. So everybody open up the homework that was assigned last night. I'm going to pause a second while we do that. Okay. So here is our assignment that we started yesterday, and you're going to finish that for today. Beware, the numbering on these are kind of strange. Remember how this, from this line up, that was all one problem? You know, this part, this part, this part, this part, this part, and this part were all coming from that triangle. Okay, same thing on this number 7 here. This all comes from this triangle here. And you can't trust how the triangle is drawn. It says it's 45, then it's 45, even though that doesn't look like a 45-degree angle. You got to know that the drawings aren't to scale. All right, so these are the easy ones, and I would recommend doing those yourself at home. Right now you happen to have a partner, which means it's easier to do some of these harder ones, like this one. All right, there's a big leap you make early, and let's just all be each other's partner here at the beginning of this one. Somebody's going to notice something that's like not to scale, and therefore probably will help a lot. What do you see? What is an equilateral? Excellent. That is actually, even though it totally doesn't look like it, it's actually an equilateral. What do you mean equilateral? Well, it's got equal angles and therefore equal sides. Doesn't that tell you a lot? Yeah. Then that means this is 2 and this is 2. Does that answer the question? No. Remember how I said don't just try to figure out x. You have to figure out something else first. You know what I mean? Well, we figured out our something else first. Now you can go through and it's a pretty easy one. Okay? But that one's pretty easy from here. I bet you can do it. Remember, if this says this is x, then that means they're equal to each other. They're the same. So don't do it twice. That'd be dumb. Okay. How about this one? Remember how I said if there were nested triangles, I pull them out separately, and then I can figure out which triangle I can actually work with? One of these two triangles that you see here is actually 3. My bad. There's 2 right triangles, though, the red one and this blue one. One of them you can work with because it's got a side given, and the other one you can't work with yet. So pull it out. You'll be able to see which of the 2 triangles you can actually do something with, which one you can deal with, and then figure out its sides. Then you'll be able to transfer over, because these triangles share a side. It's a lot like that one I just practiced with you a minute ago. Okay? I'd recommend doing this one together with your partner right now, because it's kind of medium challenge. Then there's only one more left, and it's this guy. A little of a tougher challenge. All right. So that's all I have for the video for today, because we're going to be doing the top 20 here in a minute. And I'm going to stop the recording at this point. Your homework is to finish that day 1's homework assignment completely and be ready to grade it tomorrow. All right, so you guys work together while I'm working with the tech people here.